panel's going to be moderated by Mike Demler, Semiconductor Industry Analyst. And our panelists will be Sakyasingha Dasgupta, founder and CEO of EdgeCortix, Gayathri Radhakrishnan, partner at Hitachi Ventures, and Sailesh Chittipeddi, Executive Vice President, GM and President of Renesas USA. So would you join me in welcoming them to the stage?
Hey, thank you. Thank everybody for hanging around late. We're getting cozy. You guys should all move over and get cozy too, so we can all see your faces. I think we're fortunate. We have three very interesting perspectives on this topic from the point of view of a startup, AI accelerator startup, investor, and building system solutions for the end customers. But I'm an analyst. So I think there's probably a lot of meaning implied in this topic, but I'd like to break it down. And I'd like to start with the term the edge, because I understand the cloud, and I've been covering this area for a long time, but the edge should be a one-dimensional line. It used to be just the boundary between the data center and everything else. But now the edge is being applied to everything that's not in the cloud. So I'd like to get each of your perspectives. Maybe we can make some more well-defined boundaries here. Is the edge just a completely fragmented space? So there's no one size fits all? Is it a continuum that has a possibility of having a scalable solution? Or are there distinct segments? Now, there's a lot of possible answers there. I'd like to get each of your perspectives.
You want to lead off, or?
Sure. So, I think there are multiple perspectives of looking at the edge. So if I had to classify the edge, I would rather call it a continuum rather than anything else. I think it's safe to say that any application that has strict swap requirements, whereas size, weight, and power, those would be well classified to be on the edge side. Those are typically distinct from the data center. Mm-hmm. The second thing that I would typically look at calling something edge is largely there would be a lot of diversity in the types of applications, as well as a heterogeneity in the types of processing elements that would work together to bring a solution with those swap the constraints in place. And then finally, I think across that continuum, across, let's say, a milliwatt level, from sensors all the way to even small-scale servers, do fall, in my opinion, within that edge category. Mm-hmm. So that's kind of our perspective. We as a company at EdgeCortix, we are focusing on what I would say in the few tens of watt range of that continuum, where it's a distinct segment, which is different from, let's say, at the lower end of close to IoT or Internet of Things, where you have very, very limited power size constraints. And in that middle zone where you're a few tens of watts, you still have similar compute requirements of, let's say, tens of tops of compute, but you still have quite stringent power requirements as well. So that's kind of our sweet spot in terms of edge.
Go ahead. I'll give my perspective.
So I think of it as
Mic on?
I believe so.
Okay.
I think for this, I'm also loud, so I think we're good. I think of it as a continuum from the IoT to maybe the edge gateway. But that said, from an investment perspective, and I do look at companies, I look for two characteristics. One is price and power. So the more you shift towards the IoT sensor type of, you have a low power budget and you have a low cost budget as well as low price point. But as you move maybe closer to the gateway, you have a little more power, a little more. So business models matter. Fragmentation also is higher on one end versus the other. I think the entire edge is fragmented, but there are buckets within that. That's kind of how I look at it.
Thanks. I mean, I don't necessarily, I agree it's a continuum, but we kind of make a distinction between the edge and the endpoint. So for us, it's a very simple distinction. Anything that has to do with the endpoint device, whether it's sensors or whether it's your smartphone, or as a different case may be, right? It's primarily the endpoint. And that's where the issue of power consumption starts to matter much more. You're sort of looking at a domain of 5 watts and below, essentially in terms of the domain when it comes to the endpoint. When you talk to the edge, it's a little bit different. It's really, you're talking about edge servers and so on, where the domain starts to be a little bit different. And the AI requirements also tend to be different because the power budget actually starts to go up, right? So you have this issue of cost. Certainly that's an important element of it. How much memory and power is basically consumed. And then at the endpoint, certainly, and the edge, the other issue that matters a lot is the issue of latency. So latency is a super important factor when it comes to the edge of the endpoint. And not to underestimate it, the other important factor that also plays a role is security. One of the reasons why intelligence is moving to the edge is security is a key element of what needs to happen at the edge or the endpoint of the device, however you may choose to call it. Okay. So I view it as, we make a slight distinction, but it sort of is a continuum, if you will.
So next year we should call this the AI Continuum Hardware Conference. Okay.
Yeah, it's going to be seamless sometime in the near future, don't get me wrong.
And if I may add to that, I think, the other way of distinguishing between, let's say, a cloud versus edge,
Yes.
not necessarily endpoint and edge, it's really the software requirements as well. Very different software requirements as compared to, I think the previous speaker was talking about networking scale at the data center, very important at that scale, but you will not have that same in networking problem and the software problem that goes along with it from an edge perspective. Right. So when we look at a solution where power becomes important, the software piece also becomes very, very important in many cases to tie endpoints and edge in a distinguishing manner compared to what you would have in a data center.
Okay. So that brings up two questions I had in my mind. First, you mentioned latency security. Just in general, I think the same questions apply regardless of looking at balancing a trade-off between the cloud and on-device or near-device processing. What other requirements do you see that really drives doing the computation in the continuum versus in the cloud?
And it boils down to data size, right? How much data are you trying to handle? You're never going to be in a situation where you're trying to do weather forecasting on a microcontroller. That's never going to happen, right? So you have to look at the workloads. It's going to be very workload specific at what workload makes sense to run at the edge of the endpoint and what workload makes sense to run on the cloud. So it's largely going to be a question of how big is the data set that you're trying to handle. And for every instance, you're not going to need an LLM type processing capability, right? You're going to need different kinds of processing capability when you're moving closer to the endpoint of the device, endpoint of the network. Mm-hmm. So you really have to think about it from the perspective of what is the workload, what's the problem you're trying to solve, and what kind of models would make sense in that particular domain.
What do you see?
I have to agree, but I'll also add to that around memory constraints. While they were talking the previous session, they were talking about networking at scale. The memory that you have in any sort of edge device or edge server also goes down. So your compute capacity is limited by the data it can fetch. So to Sailesh's point, it really comes down to the workload and the data set and the size of the data set. So I think that's a super critical aspect as well when it comes to the edge. Yeah.
Okay.
I can, try and break it down with an example of an application, right? It's a very recent application that we came across recently. You would have traditionally not thought of that to be an edge problem. So the application tries to essentially solve a video streaming problem. Let's say, I think all of us are using Teams or Zooms, for example. And, a bulk of the work that we are doing is in Japan. And there is a lot of difficulty in, let's say you're speaking in English, but the audience wants to hear in Japanese, or vice versa, it could be any other language. And if you're in a live video streaming application, you need to be able to real-time translate that language. And at the same time, if you're in a video streaming, you can use generative AI today to match the lip movement for the language that you're speaking in. And there's a brilliant new software company that's trying to solve that problem. You wouldn't have classically thought of that to be an edge problem. So that's a generative AI application bringing LLM capabilities, requiring very low latency capabilities to run directly on the device, converting that typical problem that you would see in a data center into an edge relevant solution.
Sure. Got it. Okay. Let's get back to that question you brought about software. And when you're balancing trade-offs and trying to design an edge solution. Which is first, the software or the hardware?
I have an opinion.
Okay, please,
Having
please.
seen companies, I think software, just because your hardware can be the greatest, but if your application layer is unable to understand the capabilities of the underlying hardware and tap into it, then you're kind of, the hardware improvements that you've done don't really matter, right? So, but that said, most of the application developers, I don't know how many developers we have here, at least based on my conversations, I've found that they don't want to go into the low level. They don't want to understand, hardware level instruction set and so on. So how do you make it easy? How do you make it seamless for them to, digest the hardware that you're providing and enable applications to run seamlessly on them. So I think it's an end-to-end package. You can't just say, okay, here's the amazing hardware, just go nuts with it. I think it's
Seen some startups fail because of that.
Yeah, I have to agree to that. I don't know. I'm sure you have a point, but I have to agree from our perspective. And when we started with EdgeCortix, we always took a software-first approach, and the idea was very simple. The reasoning why the software comes first is there is always existing hardware. Whenever you start with the problems, if I've, let's take that same example, video streaming, language translation, there's already existing hardware in the market. It could be a general purpose CPU, x86, ARM, it could be any other AI co-processor that already exists. So the question for us was, what do we do on the software side that without even bringing the new hardware to the market, with a very fast time to market from that perspective, can we leverage existing hardware that already exists and provide a solution? That's the first step. From that perspective, software comes first. And then we started looking at building AI hardware that would fit very well with that software, leverage the inherent parallelisms that exist in a neural network. So in our experience, software came later, or rather hardware came later, software came first. And that allows us to do a lot of the heavy lifting with many of the existing hardware, whether it's microcontrollers, microprocessors, or other types of hardware in the market.
Okay.
So I agree both with Gayathri and Sakya on this one, but I'd start actually with a more basic and fundamental premise, which is what is the problem you're trying to solve, right? And that's got to be the basic starting point. After that, you can kind of work. I mean, look, you can run an LLM on any processor. The question is, how efficiently does it run? That's where the hardware starts to matter, right? So you start with what problem you're trying to solve. And then you try to figure out, how do I skin this cat when it comes to hardware? What could run it most efficiently? Is it going to be something with a deep neural network? Or can the problem be solved with using a 16-bit microcontroller or a spiking neural network if it's the simplest of what has to happen? So hardware sort of comes after, when you're trying to make the scope of the problem much more efficient relative to how you're trying to run how to solve the problem, if you will.
Okay.
Maybe if I can add to it, I'd also say, thinking about the hardware architecture and how scalable can you make it, because as much as I said, software comes first, but you can update your software with much more frequency than you can. You're not going to be taping out chips like every month or so, right? So you have that cadence, but the technology has been evolving in the last 6-7 months. We are going through this big generative AI craze, which was not there before. So a lot of edge companies were not anticipating LLMs or generative AI at the edge. They were thinking about, CNN or SNN and so on, right? So how do you think about an architecture that allows you to scale as, software innovations happen is also important, I think. So it's not just hardware, software, but combine the architecture and what are you really planning to,
And making it future-proof.
Future-proof.
Exactly.
Yeah,
As
have to
much as
agree.
you can.
Right. So is there even such a thing? We're at such a rapid pace of innovation in the software side of the model development. Is there even any hope? What's the future? 2 years? What's the lifetime of the hardware?
I actually have to challenge that. As an investor, I probably shouldn't say this, but too much of anything causes whiplash and people will pull back, I think. So if something's happening every month, like at a fundamental level, you need time for anything to be absorbed and digested, especially when you're talking about big companies that are consumers of this technology.
Yeah.
So I think there has to be a built-in timeline. The question is it 1 year or 2 years? Right.
Yeah, I have to say that that's really where the hardware architecture aspects comes in. Now, I take the view that if you're building hardware which is future-proof, it ought to be a lot more operation-centric rather than operator-centric. What do I mean by that? So you have things like convolutions, transformers, fully connected networks. These are operators, and you will always have an evolving landscape of operators. But the fundamental building blocks of that AI compute, the neural network, the operations that it works on, whether we talk about multiplication, accumulation, or anything else, that does not change dramatically, or that really hasn't changed.
Correct.
So if we are building a silicon architecture and the fundamental building blocks are more operation-centric, in our opinion, that's going to live longer. And of course, you've got to innovate a lot more rapidly, as Gayathri mentioned, on the software side. The second aspect is that there ought to be some degree of flexibility on that hardware itself. So if we have too much of fixed, we build domain-specific processors, but we don't necessarily build it to be tailored to one specific type of operator, let's say convolution. So when transformer comes along, it becomes obsolete. As a result, we are focused on some degree of a hardware, so I can speak from our experience, which have some degree of flexibility, some degree of programmability, not necessarily as much as the general purpose compute, but some degree of adaptability to a changing landscape of the model. And I think that's relevant for the edge as much it is relevant for the data center as well.
No, I agree. I mean, look, I agree with that perspective. And I think the idea really is one-size-fits-all approaches won't work for the long term. You need to have some level of flexibility built into the hardware so that as the models evolve, right, you have the ability to respond to the changes. And I think some of it that you're seeing, right, today, you have GPUs certainly which are dominant today. TPUs for certain kind of applications are already dominant today. CPUs work for the simplest of stuff, right? So just based on the kind of challenges that you're dealing with, you're going to have one or a combination of those solutions to address the workloads that come in the future. And again, we can talk about LLMs today, right? People are looking at how can those models, the transformer models, be applied to the edge of the endpoint. We are looking at it. There's techniques like quantization, there's techniques like pruning that are used. How do you take those large data sets, make them relevant to the scale of the problem that you're trying to address? And those are going to start to play an important role.
Okay, so let me pick up on the Gen AI topic. We've gone from the AI hype craze, now we're in the Gen AI. Everything that was being labeled AI is now being labeled Gen AI. And some of them just are beyond me why. But so you mentioned the one I kind of get with real-time language translation, perhaps. Even there, we need to talk about how much that is Gen AI versus just traditional AI. But what applications that you can conceive of for Gen AI on the edge couldn't be run as easily or better in the cloud?
Yeah, look, power determines it.
Power.
Power is an important factor. And again, the amount of two aspects matter into it. Power isn't one element of it. The other element is the cost. Obviously, it's going to be prohibitively expensive to run every workload on the cloud that you have, right? So there's going to be a ton of applications that play into it. Now, if you're asking a separate question, which is what kind of applications that are applicable that to run on the cloud today would be in the future be relevant. I think Sakya gave you a good example of what was happening in terms of natural language processing is an area where you could start. We started out with keyword spotting on microcontrollers today, right? We extended it to a certain level of voice processing on today's processors. Tomorrow, you are going to extend it even further and start to go after more and more natural language processing capabilities at the edge of the endpoint. Would transformer type nets be important for that? Absolutely. So you can think of an evolving stage where these kinds of applications start to play a role.
And I'm sorry, go ahead. So if you recall Andrew Ng's talk, right? He talked about the fact that we started with natural language processing, LLMs, but clearly the next innovation is going to be the vision chat GPT, so to speak, right? So the interaction that we are having today, or we have with the device, we do that with natural language, but there is a lot of interaction that is forthcoming that's going to be visual based. So the same latency issues that we face today in natural language communication, similar latency issues come even when you're using vision. So for example, let's say in the same context of video streaming, we want certain ideation to take place. So in that case, let's say we are using some tool that allows us for searching a database. In that case, I can look for vision-based cues rather than, let's say, pure speech communication. And those would be relevant from an edge workload perspective. It would not be as efficient to constantly move data from that edge environment to a data center, for example. So I think those are a few examples. Having said that, not all generative AI applications that we see today, let's say a large language model with 70 billion parameters, I don't necessarily see that running on an edge environment as we are talking about today, largely being constrained by power as well as memory requirements.
Yeah.
So I think those would be the trade-offs. I think there are a lot of applications, some that we can foresee, some that we cannot. Natural language processing being a
Well,
case.
I mean, multi-factor authentication, right? I mean, you could have somebody comes in, say into a restaurant of the future or a store of some sort, right? You automatically get to know their preferences right away. You don't want everything to go into the cloud. You want a future where somebody walks in, the guy knows these are the 4 or 5 things that his taste, and you're able to administer that to him. Now, things like this are already happening, by the way, so it's not something that's too far into the future. It's in the near future that you'll see those kinds of applications. It's largely boiled down to personal kind of tastes, and that's where you should think about edge and AI much more. When it comes to personal preferences, how do you make it relevant for personal preferences? And that's an important element of what's going to change as you look. Yeah.
So to add to the both personalization and sort of multimodality that Sakya alluded to, I would extend it beyond vision to maybe even sensor data. So industrial use cases, if you're a manufacturing plant, you have sensitive data that you don't want to leave the plant. You may have an edge gateway, but you may be looking at novel sort of use cases around maybe predictive maintenance, where now I don't need to be a top tier data scientist, but a plant manager can just ask what's going on with my plant, like is there any issues, and then based on all the data that's there, it translates it back. Maybe I'm giving you some scenarios where it doesn't need to happen at the cloud. It can happen at the edge, because it's, again, we're not talking about large models, foundation models, but it's a foundation model that's customized for that use case. So very user-centric, use case-centric maybe models, right, that take into account multimodality and have security issues, and so you want to run them in the edge.
Another example in that same line of thought is visual and text-based prompting. And I think Andrew Ng also alluded to that fact. So for example, you now have pilot training schools that are trying to deploy solutions over the course of the next 2 to 3 years, where you can have these headgears that you can wear, which have essentially not a virtual reality, but essentially an augmented reality aspect to it, where you can have visual prompts or text-based prompts to enable those pilots to fly these planes a lot better or effectively learn quicker. That's an example where you might not want to essentially transfer all that data, especially if you're in a real-world flight environment, you might not want to transfer all that data to a cloud and come back. Very, very latency sensitive, and in some cases could be privacy sensitive. I think healthcare is another example area where I can foresee, let's say, radiologists using such similar prompts today. A lot of that is being done by pure vision algorithms, where you're, let's say, detecting, taking an X-ray data and doing some analysis a lot more quicker, in many cases more accurately than a radiologist. In the future, that could be augmenting or enabling the human even better with some kind of visual or text prompting that happens live, real time, directly at that environment.
Yeah. I want to make sure we have some time for questions from the audience. Do we have any right now? There's one in the back.
Okay, I think they talk about data privacy, right? And when everything is encrypted, do you still see a privacy issue?
Yeah, Look, you want to take a crack at it? And no, let me go ahead. So, yeah, of course, I mean, data today can be encrypted in a number of different ways. The question is, can you hack into it, right? And how good is your ability to hack into the systems and how much data is exposed? I think it's more a question of how much of your data is going to be exposed rather than how good are your encryption systems. So to me, the magnitude of the risk is greater when you talk about the bigger data sets that are involved, right? So on a smaller scale, obviously, you got to be prepared against side channel attacks and stuff of that nature, and you can put in tamper resistance methodologies. But one of the important reasons why you want intelligence to move to the edge, in addition to privacy and security issues, which are super important, right? And you alluded to healthcare before. Ideally, you want to be in a situation where you have your data set close at hand and you can extend it, say, to your doctor and not have that data transferred to a bunch of insurance guys, right? Think about a situation of how much hazard, moral hazard, that actually poses to you if you have a one-on-one discussion. So those are the kinds of situations where the amount of data and the quality of the data starts to matter much more. And so encryption, yeah, I agree. It'll make it more safeguard against hacking and stuff of that nature. But the amount of data that's exposed is the bigger risk factor when you talk about the cloud.
I mean, just to let you guys know that cloud is addressing all these issues, and safety and security is very, very important at cloud, and people are trying to make sure that even the cloud operators cannot look at their customers' data, right? That's the kind of privacy they're looking at. So with that kind of infrastructure, I don't know whether people can always make an assumption that
It's the
edge
tra-
is safer.
The number of exposure points,
Yeah.
right? It's the cloud may be secure, your edge may be secure, but there are, number of transition points that the data needs to make between the cloud.
Hops.
So it's your security is as strong as your weakest link, and if the weakest, so the less the surface attack, the radius of the surface attack, right? You want to minimize that. And frankly, and besides privacy, it's also around latency. You don't want to send everything to the cloud and back, even if the data is encrypted and even if privacy is not an issue. It just doesn't make economic sense as well. And that's why one of the differences between cloud and edge is, you don't necessarily talk about training at the edge, you talk about inference at the edge. And, cloud handles both training and inference. So the ideas around some of the real-time use cases, privacy is one of them, but it's not the only one, right?
And obviously power consumption is a very important element, right? And the amount of memory that's basically needed in some of these systems.
Yeah,
So you're going to need, go ahead.
Yeah, I would say that we cannot look at privacy in isolation from power and latency. I think all of those are a collective that is very important from an edge perspective. So as Gayathri mentioned, privacy is important, but at the same time, there's a huge cost of moving all of those data. It's a lot better if I can move metadata to the cloud. That reduces even the overhead that you might have for storage in the cloud. And it also reduces the amount of data bandwidth and the power that you would require to move all of this data, not just talking about latency itself.
Yeah.
So collectively, I think privacy, latency, power, all three play a big factor for edge.
And encryption and decryption don't come for free as well from a power standpoint, right? There's cost associated with that.
Exactly.
So this concept of personalization, it sounds kind of cool, but it gets to that question of security and privacy. And right now, okay, we all carry around a phone, and there's been issues that need to be addressed in keeping the data in your phone. So that's my device. That's the data that I'm carrying around with me. But you're talking about, I go to a restaurant. Well, is the data resident there? Does it in me, and then I communicate and send it to it when I walk into the how do you see alleviating the concerns of the average person in their data is just now, not just in their relationship with Google or Amazon, but with every establishment that they walk into?
Yeah, and I mean, it's up to you how much access you want to provide, right? So fundamentally, it's going to boil down to that. Even on your phone today, right? You have the option to turn off location services.
Yeah.
Obviously, it creates challenges of its own if you're trying to write on Google Maps, trying that technique. But I'd say the access is left to you. That's the important aspect of personalization services, right? It is the choice is ultimately up to you. How much security are you willing to give up in order to access some of these services that you want to have, right? So, for example, if it's a store that you're going to on a day in and day out basis and you want them to have a high level of personalization for you, you'd open up the access. But then that's how you're mitigating your own risks, you're assessing your own risks, and accessing the services that you prefer to access in that particular environment. In that instance, right, in the store instance, most of your intelligence would actually be at the store, at the network edge of the store. So it's not going necessarily into the cloud. On the other hand, if it's logistics and tracking something, that data could very well reside both at the store level as well as at the cloud level or the warehousing level in terms of what happens, and ultimately at the corporate level. There are some great examples of companies like Geo that are doing fantastic stuff when it comes to some of these technologies that are being implemented, all the way from the main data center down to the store level in terms of tracking individual things. And it's fascinating to really look at how AI is transforming the landscape.
And I guess that's the entire point of the edge. So you want to be able to give the ownership of the data back to the user as much as possible.
Yeah.
That's just not possible if you have a purely data-centric solution. And that's not to say that everything can be converted into an edge-relevant solution. There's clearly a lot of solutions that require a data center. But the whole idea is that I would take a little bit of a controversial view that if you want all the benefits of AI, there is a trade-off that one has to do. Because clearly, you cannot have the benefits of AI without all that data. So you have to be willing to let go of some of that data. And that's the necessary evil that comes with it. But the edge provides the added benefit of privacy that we were talking about. So in use cases which are edge relevant, there, by keeping a lot of that compute towards the edge, we can take back some of that control, which you will not have if it's a pure data-centric solution. I think that's the trade-off. But at the end of the day, you will have to give up some of your data if you want to have all the benefits of AI.
It seems to be a case of who do you trust?
Yes. Yeah, absolutely.
We already do it, right? I mean, I choose to buy a ton of stuff on Amazon just because it's convenient. Now they know when my kid is turning, going to school. They know, she got a new puppy because she's buying all these dog stuff. Oh, she has a senior citizen in her home because so if they choose to, they can, and they probably already do, right? So that's the trade-off between convenience and not. But it really comes down to use cases like healthcare. I don't want to be discriminated if I already have a prior proclivity towards a chronic condition, right? I don't want my insurance premium to go up because they know that based on my genetic data, I have
predisposed to
I'm
something,
predisposed to something. But on the other end, to use the restaurant example, if I'm a frequent visitor to the restaurant, I would appreciate it if they don't have to ask me, do you want, sparkling or still, or would you like, if they just bring me my glass of wine that
I get it. My wife redefines the menu at every restaurant we go to. That would save us a lot of time.
And it's not no different from going to Netflix, right?
Yeah.
When we use Netflix, it gives you recommendations. And I think all of us enjoy having recommendations that are relevant to our choices that we have historically made. And I think that's no different when it comes to the edge workload.
Okay. Do we have time for one more question? Is there more?
My favorite edge application, and one that hasn't come up in the discussion so far, is autonomous driving, autonomous vehicles. So my question is, we're probably short on time, what's the intersection between autonomous driving and generative AI or ChatGPT for that matter?
You'll take a crack. I'll follow. Go ahead, Saket.
I don't know the intersection of generative. I think that's probably a little bit of a stretch. Clearly, autonomous driving or applications in whether that's driving or maybe a drone, it's very relevant from an edge workload perspective. I cannot immediately see a lot of applications of generative AI per se. Maybe in the sensor fusion space where you're working with different types of modalities, let's say LiDAR, radar, RGB cameras all mixed together. There is some work that is happening in the simulation space. So for example, it's very difficult to get a lot of training data in the real world with driving. Even at Waymo scale, having a large number of fleets of cars. And I think one of the reasons why we haven't seen autonomous driving being as already available at that scale, despite all the promises, is because of the data shortage. And there has been entire body of work looking at simulation that's, I think it's not very edge relevant, but that's probably an area where within the simulation environment, you could use generative AI techniques to essentially come up with scenarios that would be real world relevant, and then train an agent that can be then deployed in, let's say, a practical automotive scenario.
No, yeah, I agree. I mean, I agree. That's a great example. And you can extend that concept, right? If you really buy the concept of a server on wheels for the vehicle of the future, then obviously the large amount of data sets that come in, right, you could use generative AI for the purposes of analyzing those data sets. So will that be relevant in that environment? Yes. But will edge AI will in particular be relevant for some subset of that overall data that's being handled? Okay, so when you think about vehicle architectures of the future, they're going to look a little bit different today. It's not going to be all a CPU based. You're going to have much more zonal architecture based scenarios. Within a zone, you could see edge AI playing a role. Between the CPU engine and the central compute engine, that's where generative AI could probably play a much bigger role with all the data being fed in. So local handling would be handled by subset, and then the larger data sets. Now, if you were to ask me the extension of this question, which is when will level 5 come into being, probably towards the tail end of my life, but that's probably when I say level 5 would probably make a ton of sense. Although, no insult to the companies that are working on it, that's not my view, but it'll still take some time.
Well, and if I could just one comment, because I cover autonomous vehicles quite a bit, is we talk about large language models and just voice-based UIs. If we could get an actual reliable, robust voice-based UI in the car, and Gen AI could solve that, I would love it, because in my car, if I ask Google or ask BMW, forget it. When I'm talking to BMW, it doesn't know how to respond. So building that into the car would be awesome, to know everything about what's happening in the vehicle, and especially if you're not even driving, you'd be having more interaction with the vehicle itself. So I'm sorry, that went way too fast. I did not expect it to, but yeah, you guys are pretty good panelists, so why not?
You're a great moderator.
Yeah,
Thank you.
thank you.
Thank you.
Thanks, guys. Thanks,
Thanks
guys.
for your time.